So welcome everyone. Welcome to today's session. So today is our fourth live session for atomic physics. In the first three sessions, we spent a lot of time, काफी time we spent to develop the models. In first lecture, we understood the light, then we studied the Thomas and Rutherford model. Then in the last class, we studied the Bohr model. In the last class, I said that in the next class, which is today, we are going to cover the problems. So in this session, I'm just focusing on the problems. We will be doing some problems and more or less all the PYQs, type of PYQs will be done in today's class. So if you understand today's questions, then you are done with all the kind of questions that can come. Okay. And then also I have given you one assignment which you can do, and then later on tomorrow we can have a discussion. So after the problem session, I will take all of your doubts. So let's begin the session. So this is your question number 1. So have a read of this question and then I will start explaining. So first we will cover CSIR net PYQs. So this is one of the PYQ. So please have a read on this question. What do you get from this? So let me read it for you. So consider given the ground state energy of the hydrogen atom is minus 13.6 electron volt. So ground state energy of hydrogen atom is minus 13.6 electron. What is the ground state energy for positronium? What is positronium? They have given as, they told us what is positronium, which is the bound state of electron and positron. Okay, so let's understand first of all the question. Yes, answer number A or B? B, na? B will be there, right?
B, sir. B.
Minus 1. So first of all, let's understand that what is positronium. Normal hydrogen. What is normal hydrogen? In normal hydrogen, you have a proton in the middle. This is a proton. And then electron is revolving around the nucleus. But in case of positronium, you have a positron in the middle. And then the electron is revolving around the nucleus. Okay. So instead of proton, now you have a positron. What is the difference? Mass of the proton is very, very big. Proton is a very heavy particle. So mass of the proton is almost 1837 times mass of electron. Remember this number always. This will not be given to you in the problems. This you have to remember. That mass of the proton is roughly 1837 times mass of electron. But mass of positron is same as mass of electron. What is positron? So positron is an antiparticle of electron. So if this is an electron, then its antiparticle will be positron. So both have the same mass. One has a negative E charge, another has a positive E charge. So one is basically the antiparticle of other. So instead of heavy proton, now you have a very light positron. So whenever you replace an particle in an atom itself, then you have to use the reduced mass kind of situation. So whenever you, remember this thing, whenever you replace any particle in your atom. So let's say you have an atom and you replace some particle in it. Now you can replace your particle in two ways. One is you can replace your nucleus, or you can replace your electron itself. So either replace your nucleus or replace your electron. So whenever you do something like that, what you have to do is you have to write the reduced mass. Reduced mass. So how do we define the reduced mass? 1 by mu equals to 1 by mass of nucleus plus 1 by mass of electron. Okay, so this is how we define the mass of reduced mass. So now we can say that in our atom, instead of taking mass of electron, we have to take the reduced mass. Okay, just give me 1 second. Okay, there is some disturbance. Give me just 1 second. Okay, so I'm back. So normally what we do, क्या करते हैं हम normally in normal atom when we write the formula of, हमने radius लिखा, we wrote the velocity, we wrote the energy, magnetic movement, and so on. Many things we wrote in the last class. In all of those, we wrote the mass of electron. We considered mass of electron. But when we replace basically our any particle of an atom, दो तरीके से रिप्लेस कर सकते हैं. Either we can replace न्यूक्लियस को रिप्लेस कर दो, प्रोटॉन की जगह कुछ और रख दो. फॉर एग्जांपल इन दिस केस वी रिप्लेस द प्रोटॉन विद द इलेक्ट्रॉन. वन मोर वे इज वी कैन रिप्लेस द इलेक्ट्रॉन इटसेल्फ. फॉर एग्जांपल इलेक्ट्रॉन की जगह इफ आई से ओके देयर इज नो इलेक्ट्रॉन, देयर इज अ म्यूऑन. proton is there but now there is a muon. So in both the cases what I have to do, basically I have to write the reduced mass. And how do we write the reduced mass? Reduced mass is written as 1 by mu equals to 1 by mass of electron plus 1 by mass of neutron. Okay, and the another way we can write is by taking the LCM. If I take the LCM, it will be mass of neutron into mass of electron divided by mass of not neutron, nucleus, mass of nucleus plus mass of electron. So this is the formula for reduced mass. Okay, अब reduced mass calculate करते हैं. Now let's calculate the reduced mass. So let's first calculate the reduced mass for the hydrogen atom. Now in hydrogen atom, who is the nucleus? Proton. And who is the outer electron? Just simply electron. So how will I write the reduced mass? Reduced mass can be written as mass of nucleus, which is basically mass of proton, into mass of electron divided by mass of proton plus mass of electron. Now how do we write mass of proton? Mass of proton is 1837 times mass of electron. And there is one mass of electron already, so I will square it, and in the denominator I will get 1838 times mass of electron. So basically you will get 1837 by 1838 mass of electron, जो कि roughly mass of electron के बराबर है ना. This thing will be very very close to 1, very very close to 1. That is why hydrogen atom में हम reduced mass लेने की जगह simply mass of electron ही ले लेते हैं. Because what is happening here is that आपका reduced mass जो है वो almost mass of electron के ही बराबर आ रहा है. It's almost similar. But in case of your positronium, चीजें थोड़ी बदल जाएंगी. In case of your positronium, things will change a little bit. Who is your nucleus now? Nucleus now is positron. And who is the outer particle? Outer particle is electron. तो अब आपका reduced mass क्या होगा? Now your reduced mass will be mass of positronium into mass of electron divided by mass of positronium plus mass of electron. अब मास ऑफ प्रोजिटोनियम और मास ऑफ इलेक्ट्रॉन तो सेम है, तो ऊपर क्या आ जाएगा? 2 टाइम्स me इलेक्ट्रॉन स्क्वायर डिवाइडेड बाय 2me. सो दिस विल बी me by 2. तो पहले केस में मेरा जो रिड्यूस मास था वो me आया. ऑन द अदर हैंड दूसरे केस में मेरा जो रिड्यूस मास है वो me by 2 आया. हाउ मेनी ऑफ यू अंडरस्टूड द कॉन्सेप्ट ऑफ की रिड्यूस मास कैसे लिखना है? फर्स्ट ऑफ ऑल, बाकी क्वेश्चन तो होता रहेगा. But how many of you understand that how did we write the reduced mass in both the cases? In hydrogen atom and in positive. Clear everyone? Any doubt here? Please let me know.
सर ये रिड्यूस्ड मास का फॉर्मूला प्री डिफाइंड है, मतलब इसका कुछ
इसके बारे में बहुत डिटेल में बात सेंट्रल फोर्सेस में करें कि why from where this reduced mass is coming.
Okay.
So basically we are converting two bodies into one body. दो बॉडी है, न्यूक्लियस एंड इलेक्ट्रॉन इज अ टू बॉडी सिस्टम. अब टू बॉडी सिस्टम को उठा के वन बॉडी सिस्टम में कन्वर्ट कर रहा है. सो इन दैट केस वी यूज द रिड्यूस्ड मास. सो हाउ मेनी ऑफ यू अंडरस्टूड दिस concept of reduced mass? Writing it, how we write it? Clear everyone? What do you say? Fine, everyone understood?
सर एक बार बता देते कि ये दोबारा से ये जो रिड्यूस मास हम ले रहे हैं ना, तो ये कर क्यों रहे हैं? मतलब सर इसका बेसिक कंसेप्ट स्टार्टिंग से क्या था, थोड़ा सा मिस हो गया.
So I have actually not told कि हम reduced mass क्यों निकाल रहे हैं, but let me tell you in which case. So how I started. So I started कि let's say आपने एटम के अंदर कोई पार्टिकल को चेंज कर दिया. आपके पास हाइड्रोजन, यू हैव एन हाइड्रोजन एटम, बीच में न्यूक्लियस था, आउटर मोस्ट में इलेक्ट्रॉन घूम रहा है, ऑल ऑफ द सडन सम अदर सिमिलर काइंड ऑफ एटम इज गिवन जिसके अंदर पार्टिकल चेंज है। फॉर एग्जांपल न्यूक्लियस चेंज कर दिया, प्रोटॉन की जगह मैंने पॉजिट्रॉन रख दिया, या फिर मैंने इलेक्ट्रॉन की जगह कुछ और रख दिया, मान लो इलेक्ट्रॉन की जगह आई से म्यूऑन रख दिया, म्यूऑन। So whenever you replace the particle in an atom, in that case you have to use the concept of reduced mass. अब ऐसा क्यों करते हैं? बेसिक
हाँ
आइडिया एक लाइन स्टेटमेंट में दे देता हूं, why we do that. For example, let's take the sun and earth condition. अब earth is very light, sun is very heavy. Now earth is revolving around the sun. But is this the reality? क्या अर्थ सन के राउंड घूम रही है, या फिर अर्थ और सन दोनों ही सेंटर ऑफ मास के राउंड घूम रहे?
हाँ, सेकंड वाली बात।
सेकंड, राइट? सो अर्थ एंड सन बोथ आर रिवॉल्विंग अराउंड द सेंटर ऑफ मास, बट अब सन इतना हैवी है कि वो सेंटर ऑफ मास जाकर कहां बैठ गया है? सन के ऊपर। whenever let's say you have a dumbbell, so one side of the dumbbell and other second side of the dumbbell, if one side is very much heavier, then the center of mass of the system will almost be on the heavier side.
क्लोजर टू बी।
Yeah, so if it is so much high, ये सेंटर ऑफ मास शिफ्ट होकर हैवी मास के अंदर चला जाए। दैट इज व्हाई हमें लगता है, वी सी लाइक कि अर्थ इज रिवॉल्विंग अराउंड द सन, बट एक्चुअल में अर्थ इज रिवॉल्विंग अराउंड द सेंटर ऑफ मास, और वो सेंटर ऑफ मास ही सन के अंदर है। बट नाउ लेट्स से देयर आर टू इक्वल पार्टिकल्स, जैसे पोजिट्रॉन एंड इलेक्ट्रॉन, they both have the same mass. Now what will happen is in atom, what will be the change? Now both of them are revolving around the center of mass. So now the things are very complicated for us, क्योंकि अब हमें दोनों का मोशन डिफाइन करना पड़ेगा कि ओके ये कैसे घूम रहा है, वो कैसे घूम रहा है। So things get very
सर अब
complicated.
दोनों ही नहीं पता लगेगा कि दोनों एक दूसरे के साइड घूम रहे हैं कि कौन किसके साइड
दोनों घूम
घूम
रहे
रहा
हैं
है।
एक्चुअल में, दोनों, both of them will start revolving. So
मतलब
things
प्रेडिक्ट, मतलब सही है सर,
हाँ,
उसको एज्यूम नहीं कर पाएंगे सर, ऐसे ना कि
या उसको क्या,
मतलब कि दोनों एक दूसरे के, जैसे ये रिलेटिविटी का कंसेप्ट आ जाता है ना सर, फिर पता ही नहीं लगेगा कि एक दूसरे के साइड घूम रहे हैं ये,
क्यों
या
नहीं
फिर
पता
कौन
चलेगा?
किसके घूम
व्हाई
रहा
विल नॉट, क्यों नहीं पता चलेगा? ऐसा क्यों
है।
होगा?
जैसे कि
ऐसा हाँ,
जैसे कि सेंटर ऑफ मास था सन के अंदर चला गया, तो हमें लग रहा है कि अर्थ घूम रही है सन के अराउंड।
यस। सो
आप
तो
समझ
मान
गए
लो
ना
अगर
सर
दो
मुझे?
इक्वल पार्टिकल्स हो, तो हमें हमें दोनों घूमते हुए नजर आएंगे। दोनों क्यों नहीं घूम सकते? दोनों घूमेंगे। बोथ ऑफ देम आर रोटेटिंग लाइक दिस अराउंड द सेंटर ऑफ मास, सो नाउ बोथ ऑफ देम आर
यस।
रोटेटिंग, राइट?
ओके।
सो यू विल बी सीइंग क्लियरली। अगर आप एक डंबल को घुमा देते, लेट्स से यू रोटेट अ डंबल, सो बोथ ऑफ द masses will rotate, right? So you will see both of them rotating. So that becomes a very big problem for us. कि now अब हमें दोनों दोनों घूम रहे हैं, तो दोनों को कंसीडर करना पड़ेगा. We have to see the motion of first particle rotating, motion of second particle rotating. So rather what we do is we shift our two mass body problem, दो body problem को one body problem में shift कर देते हैं. And that we use using the classical mechanics. Classical mechanics को use करके we do that. Yeah, please.
Sir, is this like orbit similar to binary star system?
बिल्कुल, yes, it's exactly same. Binary
Okay.
star system and atom system is exactly same, right? So that is what we do. और जब हम उस two body problem को one body problem में convert करते हैं, the concept we use is known as a reduced mass. कि okay, भूल जाओ दो masses थे. Now just imagine कि आपके पास एक ही मास है, लेकिन उसका मास कितना है? reduced mass के बराबर. और बस इस मास को समझ लो, तुम्हें सब समझ आ जाए. That is the concept. Rather than studying those two particles जो कि अपने सेंटर ऑफ मास के राउंड घूम रहे हैं, उन दोनों को छोड़ दो एंड जस्ट स्टडी द एक पार्टिकल, और उस एक पार्टिकल का मास कितना होगा? रिड्यूस मास.
Excuse me, sir.
यस
क्या ये reduced mass center of mass के अराउंड घूम रहा है? Is it like that?
वो किसके राउंड घूम रहा है? वो सेंटर ऑफ मास के अराउंड ही यस घूम रहा है.
Okay.
यस, वो जो है वो सेंटर ऑफ मास के नाम. सो इंस्टेड ऑफ कंसीडरिंग टू पार्टिकल्स रिवॉल्विंग अराउंड सेंटर ऑफ मास, जस्ट इमेजिन वन पार्टिकल रिवॉल्विंग अराउंड सेंटर ऑफ मास. तो इसका पार्टिकल m न्यूक्लियस था, इसका मास m इलेक्ट्रॉन था. तो इंस्टेड ऑफ both of them revolving around the center of mass, you just study one particle. सिर्फ एक particle को study कर लो जिसका mass है reduced mass. That's it. So that is why I am writing the reduced mass. Clear everyone? Any doubt still? Please let me know. Everyone, what do you say? Understood? Now how do we write the reduced mass? 1 by mu equals to 1 by mass of nucleus plus mass by mass of electron or whatever is revolving. So everyone clear concept? Hydrogen atom and then positronium. So we wrote the reduced mass for both. दोनों के लिए लिखना आ गया, that is very important. कि कैसे इसके लिए इलेक्ट्रॉन के बराबर आया है ऑलमोस्ट एंड इसके लिए me/2 आया है. That is much more important. Fine. Okay. Now let's write this list. Then I am going to tell you the dependence upon mass. And this I also mentioned in the last class, and I said that I will explain you later on that why I gave you the dependence on mass. So how does radius depends upon the mass? Radius depends inversely on the mass. Velocity does not depend upon the mass. And energy depend directly on the mass. अगर energy directly proportional to mass है तो 1 by lambda will also be directly proportional to mass. Why? Because energy is simply equals to hc by lambda. And अगर 1 by lambda directly proportional to mass है तो Rydberg constant will also be directly proportional to mass. Why I am saying that? Because 1 by lambda is equals to Rydberg constant into 1 by n final square 1 minus 1 by n initial square. So this formula we did, right? Remember, yeah, last class we did. So if 1 by lambda is directly proportional to mass, then Rydberg constant is also directly proportional to mass. So ये जो आपके पास 1, 2, 3, 4 and 5 dependencies हैं, this should be in your mind all that. तो समझ आए how? And if you will look at the actual formula जो हमने last class में derive किए, then you can clearly see कि radius inversely proportional to mass है, velocity के अंदर mass नहीं आ रहा. And ये मैंने point out भी किया था. Energy is directly proportional to mass. If energy is directly proportional to mass, then 1 by lambda is directly proportional to mass. और फिर Rydberg constant is also directly proportional to mass. Clear everyone? This table, have you all noted it down? Note कर लिया ये. Very important. What do you say? Should I now go to the solution?
Yes, sir.
Clear?
Excuse me, sir.
Yeah, please.
Where did Rydberg constant come from in this concept? Like we were like I didn't got connection with Rydberg constant. Why are we using this now?
Question आता है वो पूछ लेगा how does Rydberg constant is depending on mass.
Okay, sir.
Right.
Yes.
Clear? So these are the very important situations. Now let's come back to the problem. So I gave you the basic ground that on which you need to solve this question. Now, given the ground state energy, so they are saying that ground state energy of the hydrogen atom is minus 13.6. Then what will be the ground state energy of positron? Okay, fine, we can do this now. So what was the formula for the energy we write last time? The formula we write was En equals to minus 13.6 divided by n square into z square. For hydrogen atom, z is equals to 1. It means your energy is equals to minus 13.6 divided by n square. And if you're talking about ground state, then n will also be equals to 1. Ground state के लिए n 1 होगा. So then your energy will be equals to minus 13.6 electron volt. But now we know that energy is directly proportional to mass. And now we want to find the energy for the positronium atom. So how will I find that? So I will just simply say that E dash by E will be equals to M dash by M. Because energy is directly proportional to mass. Okay. M, or I should say nu, which is nu basically means reduced mass. Okay. So this is for positronium and this is for proton. Okay. Or you can say hydrogen. So what is the reduced mass for positronium? Me by 2. So here I simply write Me by 2. And what is the reduced mass for hydrogen atom? That is simply Me. So then I divide by ME. So E dash by E comes out to be half. It means E dash comes out to be E by half. E is already given, which is basically minus 13.6 divided by 2. So that will be minus 6.8 electron volt. So ground state energy positronium atom के लिए कितनी होगी? Minus 6.8 electron volt. How many of you are okay with this solution? समझ आया किसको? Forget about exam. किस किस को ये solution समझ आया? Any doubt in this? कोई भी doubt?
This is applicable for the atoms which are not H like one electron.
They are H like, one electron is only there, but yeah, they don't have the traditional atom kind of thing. Something has been changed in it. Right? Clear, everyone? I hope that it is clear. So I'm okay. ये किस तरह की लाइव क्लास है भाई? हाँ ना तो बोलो कुछ.
Sir, like is energy directly proportional to reduced mass? Is it always?
Yes, always. Energy का formula drive किया ना? We derived the energy formula. In the last class, we derived energy formula. In that, you can just directly go and see that it is inversely proportional to mass. Dependence, right? Nothing in this. No fancy concept. Okay. Nice.
Okay.
सर एक बार पिछले वाली क्लास को 5 मिनट के लिए डिस्कस कर लेते सर, थोड़ा सा मतलब कि क्या क्या था, मतलब ओवरव्यू टाइप में.
So in the last class, we developed the Bohr model. So Bohr model we developed. In the Bohr model, we derived some formulas. So in Bohr model, what happens? Bohr model की एक brief सी, अगर हम Bohr model को so if we try to imagine Bohr model, then there is a nucleus in the middle, and then there is an electron revolving around it. Okay, so this is plus ZE, and then this is it. Then we derived some formula. Okay, we said that angular momentum will be quantized. हमने बोला कि इलेक्ट्रॉन कैन रिवॉल्व इन अ सर्कुलर ऑर्बिट, और कोई भी ऑर्बिट में वो रोटेट नहीं कर सकता. इट विल ओनली रिवॉल्व इन दोज ऑर्बिट्स जिसके अंदर एंगुलर मोमेंटम की वैल्यू एन एच कट के बराबर हो. या तो एंगुलर मोमेंटम की वैल्यू एच कट होगी, या एंगुलर मोमेंटम की वैल्यू 2h कट होगी, या एंगुलर मोमेंटम की वैल्यू 3h कट होगी. वो उन्हीं ऑर्बिट्स में घूम सकता है जिनके अंदर एंगुलर मोमेंटम की वैल्यू इंटीग्रल मल्टीपल ऑफ एच कट है. वो ऐसे किसी ऑर्बिट में घूम ही नहीं सकता जिसके अंदर एंगुलर मोमेंटम की वैल्यू 1.5 एच कट हो. So that was the first formula. Then we said that okay, let's use this. Then we said that okay, घूम रहा है तो centripetal force कौन provide कर रहा है? Centripetal force is provided by the electrostatic force, which is basically K ZE, which is the mass of charge of this nucleus, into E divided by R square. Then we solved this up and we found the different values of values. For example, we found the radius value, which was 0.53, then into n square by z angstrom, right? Then we found the velocity. Velocity, how did we find? Velocity was 2.18 into 10 to power 6 meter per second. And then we had z by n meter per second. And then we had energy formula. Total energy was minus 13.6 z square by n square electron volt, right? And हमने 3 फॉर्मूला और किए थे. Energy, total energy was minus kZe square by 2Rn. Kinetic energy क्या थी हमारे पास? kZe square by 2Rn. और हमारे पास potential energy क्या थी? minus kZe square by Rn, right? So this is the case.
Yes, I think.
Okay, so that was basically the basic recap we did in the last class. Okay, so now we are using this, and then you can directly see that then in this class I said that radius will be inversely proportional to mass, velocity will not depend upon mass, and energy will be directly proportional to mass. And then we did the spectral formula, which was 1 by lambda equals to Rydberg constant into n final square minus n initial square. And then we explained that okay, for Lyman series, what will be the value of final initial for Balmer, Lyman, Balmer, Paschen, all the series, and then we try to understand the spectrum. Okay.
और फंड और ब्रैकेट को भी डिस्कस किया था सर.
Yeah.
मतलब लाइमर बामर पास्टन फंड और ब्रैकेट सबको डिस्कस किया था।
Yes, we discussed everything
मतलब
last.
पास्टन तक तो क्वेश्चन आता है सर, लाइमर बामर पास्टन तक, पर फंड और ब्रैकेट के भी क्वेश्चन देखने को मिलते हैं CSIR।
उसमें क्या फर्क पड़ेगा, एनएफ की वैल्यू चेंज हो जाएगी ना बस।
कंसेप्चुअल।
नहीं नहीं नहीं, कुछ ऐसा नहीं उसमें, बल वो दैट इज इन इंफ्रारेड रेडिएशन, दैट इज नथिंग न्यू इज देयर, राइट? Only
ओके
thing
सर।
that will change is NF and NI value. So they can give you any series उसमें क्या है? Yeah. Any questions?
Sir, like I had one question, sir, like like
Hmm.
important question again. Sir, what is the physical significance of fine structure constant, sir, that alpha value?
Yeah, we will come to that. Corrections in hydrogen atom spectrum. Yeah, yeah. We will
Okay.
come. So the next topic will be corrections in hydrogen atom spectra. So fine structure we will do that time. Okay. So yeah. Okay. Now let's move on to this thing and second question basically. So an atom of mass m can be excited to a state of mass m plus delta. Now this is very strange. Okay. So take your time. You have an atom whose mass is m, and all of the sudden you changed your atom to mass m plus delta by photon capture. Okay, so what is happening here? Understand, आपके पास एक atom था, you had an atom which had the mass m, and suddenly a photon came. So let's say the frequency of that photon is mu. So this is an atom, all of the sudden frequency came, and this atom captured this photon, means absorbed this photon, and the mass of atom increased. As a result, the mass of the atom increased. Can anyone tell me that what principle is this?
Sir, is E equals MC square related here?
Yeah, yeah. So what is that named as? Mass energy equivalence.
Mass energy equivalent.
So Einstein said that energy can be converted to mass. So the energy of the photon gets converted into the mass of an atom. So all of the sudden your atom was at mass m. Now its mass is m plus delta. Okay, so this is what is happening. Now they are saying that in this process, what is the frequency of the photon which can cause this? So whatever is the frequency coming, wo kitni hai? So what is the first thing that comes to your mind? What kind of analysis you should apply as a basic physics student? कौन सी applications you should use? Which tools you will use?
So we will use mass energy equivalence first of all, sir.
Okay, mass
Conservation of
energy
momentum
equivalent.
and
E
Okay,
equals
what?
h mu.
Okay, that is formula, but I'm asking about the tool.
Conservation
Yes,
of
sir.
energy.
Conservation of energy, and one more, conservation of
momentum.
momentum. Because you are having some reaction kind of thing. So whenever you have some sort of reactions in physics, what do you conserve? You always conserve conservation of momentum, and in this case, the conservation of total energy, which will always be conserved. So now let's do that. We will just do that. So this is the pictorial diagram which you can see here. So you have an atom, mass m. You have a photon of frequency mu. So ये photon came and इस atom ने इस photon को absorb कर लिया, जिसकी वजह से इस एटम का मास बढ़ गया, कितना बढ़ गया, m प्लस डेल्टा, एंड एज अ रिजल्ट ये एटम मूव भी तो करेगा फिर. दिस एटम मे बी इट इज पॉसिबल दैट ये एटम थोड़ा सा मूव भी करने लग जाए. So if this atom is moving, then we can say the momentum of this atom is p dash. Who understood this idea? कि हुआ क्या, what is happened in the problem? Then we can go to formula.
Yes, sir.
Yeah.
Like, what is the guarantee that it will move, sir?
So if it, no guarantee, if it is not moving, p dash will automatically come out to be 0.
Okay, sir.
I have to take the general case, but let's say it did not start to move, then p dash will automatically come out to be 0 in my equations, right? So किस किस को ये आइडिया क्लियर हुआ? So you have an atom, atom रेस्ट पे था, atom का मास m था, suddenly a photon came, photon strike the atom, as a result ये atom का थोड़ा सा मास बढ़ गया, and also this atom starts moving. ऐसा हो सकता है कि ये एटम मूव किए ही नहीं, करे ही नहीं. इज इट पॉसिबल? लेट्स से ये इमेजिन करके देखो, एटम था, फोटोन आया और इसको स्ट्राइक किया. दिस एटम ऑब्जॉर्ब द फोटोन और ये एटम बिल्कुल भी मूव नहीं हुआ, बताओ कौन सा प्रिंसिपल फेल हो जाए? विच प्रिंसिपल विल फेल?
Momentum will not conserve.
Momentum will not conserve. Initially you have a momentum in this direction, and now this atom absorbed the photon and did not move. So where did all the momentum go? Suddenly your momentum became zero. Initially photon was moving in this direction, now nothing is moving, so momentum became zero. So momentum conservation fails, and you cannot fail the momentum conservation. You have to
Excuse me, sir,
conserve
like
them.
I have a doubt, sir, like one silly
Yeah.
doubt, I think,
Yeah,
like
okay.
imagine like we strike the photon on the atom,
Yeah,
like
okay.
we strike the photon on the atom.
Okay.
What if like now the electron was in some ground state?
And
What
then
if
it went.
that electron, yeah, jumped from ground state to some other state, and all the momentum transferred from that ground state to that state, and the nucleus is still in rest?
No, but okay, let's consider the center of mass of that atom. Now this atom has some
Oh, okay.
nucleus, some electrons. So center of mass of that thing is not moving still, right? So
Oh, yes, sir.
conservation
So
of momentum
center of
is
mass.
failing.
Okay.
Yeah. Okay. So
Yes,
your
sir. So
momentum will
center
fail.
of mass.
So
may
finally,
move.
so your final atom has to move. Why it has to move? Because you want to conserve your momentum. Okay, now let's
Okay.
conserve
But the mass
momentum.
is, yes, sir.
Yeah.
Yes, sir.
Yeah. Tell me.
Yes, sir. Like, but the mass is very high, right, sir? We can neglect it like 1,800 times that of electron. So we may
Neglect
just
it.
assume electron. Okay, sir.
Momentum conservation
Thank you,
is
sir.
not
Okay.
good. So now let's conserve the momentum. In order to conserve the momentum, you should first know that what is the momentum of your photon. क्योंकि जो आपका photon आ रहा है, उसका momentum क्या है? How do you find the momentum of a photon? उसकी आपको frequency मालूम है. Energy can also be known. Energy क्या होता है? H mu. But what about the momentum? What is the momentum of photon? How do you write the momentum of photon? So I'm teaching you one concept. I'm giving you one formula, which is basically momentum of photon. So momentum of photon can be written by this equation. Energy equals to P into C. How many of you are able to imagine this? That, okay, yeah, sir is saying correct. This will be E equals to PC itself. How many of you are saying that, okay, this equation I can imagine? And how many of you can give me the possible solution for this derivation? Derive. Let's derive.
Sir, like we can derive, sir, but I am not able to imagine, sir. Like how to imagine this?
No, you are just derive it. Imagine to it's an equation. Kya imagine?
Yes, sir.
It
No.
will have some momentum. Only
Yes.
imagination is that momentum will have, your photon will have some momentum. That's it.
Yes, sir.
Okay.
So we can
that's the
simply write
imagination.
E, yes, sir. E is equal to hc by lambda, then
Sir.
h by lambda is there, then that is P.
Yeah,
So E
that's
equals
it.
P.
So E equals to hc by lambda, and h by lambda is P, right? H by lambda is P according to who? De Broglie hypothesis. So de Broglie hypothesis क्या बोलता है कि P is equals to h by lambda. That's it. That's the derivation.
Sir,
समझा
one more question I have, sir. Like,
yeah.
Did this de Broglie equation come first, or Einstein's photoelectric effect came first? Which one came first?
Einstein photoelectric effect came first.
So he gave this after Einstein theory, sir. After
No.
the T.
Yeah, momentum of what can be a momentum for photon? Yeah, that came later. Yes.
Okay.
Yeah. Okay. So momentum of photon निकालने का तरीका E equals to PC. PC. So what will be the momentum? Momentum will be E by C. And what is the energy of the photon? Energy of the photon is H nu by C. That's it. So that is what I have written. So how clear everyone how to write the momentum of the photon? Please write this down. Whenever you need momentum of photon, use this formula. समझा सबको momentum of photon? Clear? कोई doubt please? Yeah. हेलो
हाँ समझ में आ गया
हाँ बताइए
समझ में आ गया ऐसा बोल रही थी
Can you repeat? Okay, good. समझ गया ना? Good.
Yes.
Great. So let's conserve the momentum. So initially photon is coming and photon has a momentum of, we just found h nu by c. Initially atom is not moving, so atom has no momentum, एटम पहले रुका हुआ है तो उसका कोई मोमेंटम है नहीं. फाइनली वी सेड दैट एटम का मोमेंटम कितना है, p डैश. सो फाइनल मोमेंटम ऑफ द एटम इज p डैश. दैट्स इट, राइट. नाउ वी हैव टू कंजर्व द एनर्जी. Momentum conservation is done, so this is my equation number 1. Now let's conserve the total energy. Okay, so let's see the first energy. So initially you have an photon. Photon की energy क्या होती है, h mu. Now you have this mass और ये रुका हुआ है. So only energy it has, किसी भी पार्टिकल की दो एनर्जीज होती है. Any particle has the two energies. One is rest mass energy and second is energy because of its momentum. Rest mass energy क्या चीज है? I am sitting, even if I am not moving, do you think मेरे अंदर कुछ ना कुछ एनर्जी होगी? I'm not moving, I'm just rest. Do you still think that I will have some sort of energy, right? That energy is given by rest mass energy. और वो कितनी होती है? mc square. m is my rest mass into c square, which is basically speed का square. And what is the total energy? If I even start running, अब मेरे पास दोनों एनर्जीज है. अब मेरे पास रेस्ट मास एनर्जी भी है और मेरे पास मोमेंटम की वजह से एनर्जी भी. So फिर then how will I write my total energy? Then you know from the relativity, then we write the relativistic energy as under root of p square c square plus m square c raised to power 4. If you don't know this formula, you will learn this in relativity in my lectures itself. For now you can have a look at this formula कि अगर आपके पास आप भाग भी रहे हो and also you have always you always have a rest mass energy as well, right? तो उस केस में in that case आपकी टोटल एनर्जी कैसे लिखी जाएगी? अंडर रूट ऑफ p स्क्वायर c स्क्वायर, p आपका मोमेंटम है, प्लस m स्क्वायर c रेस्ट पर 4, m आपका मास. ये फॉर्मूला देखा है सबने? व्हाट डू यू से? नजर में है ये? कभी ना कभी देखा होगा, बीएससी एमएससी.
Yeah. Seen a lot of times, but never applied, sir. Like never solved problems.
Okay, so this formula might be, you might have seen at least somewhere. Okay, so now let's conserve the energy. So पहले सबसे एनर्जी बात करते हैं फोटोन की. So photon is coming, so photon has some energy h mu. Now you have a atom. Now atom's momentum is 0. So if atom's momentum is 0, initially वो रुका हुआ है, so no momentum. If this is 0, then energy will be equals to m square c raised per 4 under root, which is basically just mc square. That is why I just wrote mc square. Now finally what is happening is that now your atom is moving with momentum p dash. और उसका मास अब कितना है? m plus delta. Now its mass is m plus delta. So अब कैसे एनर्जी लिखेंगे? Now it has both kind of energies. रेस्ट मास एनर्जी भी है और मोमेंटम की वजह से एनर्जी भी है. So now how will we write the energy? p dash square into c square, because momentum is p dash square. Now the mass is m plus delta whole square into c raised to power 4. This is your equation number 2. How many of you are clear till here? इतना किसको समझा? सबको? I need answer from all of you. समझा नहीं समझा? Clear or not?
Sir, so basically we did conservation of moment of and energy so far.
Yeah, that's it.
Okay.
Everyone understood? You can use the chat box if you don't want to unmute.
So last one is the total energy due to the momentum
Plus
and its rest mass.
yes.
Okay.
Great. Now just square it. So if I square both sides, so I will do a square plus b square plus 2ab. So a square will be h square nu square plus m square c4 plus 2h nu mc square. So that is just a square plus b square plus 2ab. And in this side, under root will go away. So I will just get p dash square into c square, that is this. And then I will open up this square. So I will get m square into c4 plus delta square into c4 and then 2m delta c4. That's it. Right. And then I will just simply cancel the terms. This term and this term will cancel each other out. And now I will use this thing that I already found out what is p dash. So from the equation number 1, p dash is h nu by c. So I put the value of p dash as h nu by c. So I get h square nu square by c square into c square. So c square cancel, and I am left with this h square nu square. I also have one h square nu square this side, so that and this will cancel each other out as well. So now I am left with this 2h nu mc square and this thing. From this thing, I can take 2m delta C4 constant. So if I take this thing constant, so I will get 1. And in this, I am left with this 1 delta. So this is there. C4 is already taken common. There is no 2m here. So I have to divide by 2m here. That's it.
Sir, that p dash square, how it changed to h
I
square?
use this. So P dash is equals to h nu by C.
Oh, okay.
Right. So I put that value. So h nu by C becomes h square nu square by C square. And then from here, you can directly see I cancelled m both sides. I cancelled c square like this. Delta remains as such. C4 and c square cancel. So I'm left with the c square. Then I took this h on the denominator and 2 also cancelled. So my frequency is delta c square by h plus in bracket 1 plus delta by m. So now I can take this 2m as LCM. So if I take 2m as the LCM, I can get 2m plus delta, and then I will get 2mh in the denominator. So this is my answer. And if you carefully look at the options, this will be your correct option. Clear everyone, this solution? Yeah, please.
Sir, E is equal to PC only for photon, or we can use for particle also?
Only for photon. Only for photon.
Okay.
Because for
But
particles,
for
you
particle,
cannot have C, right?
yes. For particle,
For why
for
I'm saying
particle, what should I use for particle moment?
that
Equivalent.
this formula, right? Why I'm saying for this will be, so let's say for photon, what is the rest mass of photon? 0.
Yes,
Rest
sir.
mass of photon is 0, right? So if I put rest mass of photon 0 here, what will I get? Under root of p square c square, which is basically simply what? Pc, right? What do you say?
Excuse
Yes.
me, sir.
Yeah, so that guy, yeah, completed. Yeah, who asked the question?
Yes, sir. Like, sir, if possible, can you show like this energy equation? Like E is equal to square root of p square c square plus m square c4. How it gets reduced to half mv square in less velocities?
Oh,
Like
that
both
is
look
complete
completely
derivation.
different.
वो पूरा derivation है sir, वो करना पड़ेगा
Okay,
ऐसे
sir.
ही.
Okay, sir. No problem.
हाँ.
Yes, sir. Okay.
That was asked to me in interview once. In some ISER, they told me that do that derivation. Okay. Yeah, clear? Someone asked. Please. Yeah. Yeah. I'm not getting your voice. Can you write maybe? आपकी voice is breaking. Okay.
Sir,
Yeah, please.
so this conserving momentum question that you got h nu by c plus 0 equals to p.
Yes.
So that the 0 is like that. I did not get that equation.
So let's conserve that momentum. तो आपके पास एक तो फोटोन है, फोटोन का मोमेंटम मैंने लिखना सिखाया, E equals to PC. तो मोमेंटम कितना आ गया? E by C. So what is the energy of the photon? H nu by C. Energy of the photon is H nu. So momentum of the photon came out to be H nu by C. So photon का momentum is H nu by C. Now your atom is at rest, so उसका momentum 0 होगा. And finally, जब photon atom के साथ टकराया, atom started moving with the momentum P dash. तो final momentum कितना होगा? P dash. Clear?
Yes, sir.
Okay. In the ISER, they said that if I take C as very small speed, for example, our daily life, then this energy should convert into half mv square. So prove that for low speeds, this formula will convert into half mv square. So that was the derivation they asked in ISER. It's 1 page long derivation. Okay, not a very straightforward.
Okay, sir. Let's focus on problems.
Yeah, I will send it. I have that. Okay, so very standard derivation. Okay, now let's move on to third question. In negative muon, which has nearly 200 times that mass of electron. So you have a negative muon. So mass of the muon, which is mu negative, is 200 times the mass of electron. It replaces an electron in lithium atom. So now again I'm doing the changes in an atom. So I have a lithium atom. In this lithium atom, now I didn't change the nucleus. मैंने nucleus change नहीं किया. I changed the electron. I changed the electron with the mu, which is basically muon. And the mass of this muon is 200 times mass of electron. So मैंने electron की जगह muon रख दिया. Now they are saying that the lowest ionization energy for the muonic lithium atom. So ये जो आपका नया lithium atom है जिसको they are saying muonic lithium atom, उसका ionization energy क्या होगा? So कौन सा concept लगेगा इसमें? Now you know.
Sir, is the answer C? Maybe I may be wrong.
Yeah, it is C.
Like,
Which concept will be applied, everyone?
Like you said, like energy is directly proportional to mass. So I simply multiplied by 200 and somehow got the answer.
So that can lead to much problems. Okay, you have to check that.
Yes, sir. Yes, sir.
But which concept? Reduced mass, right? Because I'm changing something in an atom. So reduced mass concept will be used. So reduced mass find करते. So first of all, normal lithium के लिए reduced mass निकालते हैं. When we have a normal lithium. अब normal lithium में बीच में नीच में है 3 प्रोटॉन, मतलब नॉर्मल लिथियम का मास नंबर कितना होता है? लिथियम का मास कितना है? 7.
Oh, yes, sir.
Lithium के लिए mass is 7, right? It is basically 6.9 something, so it is almost 7.
Yes, sir. 3.
So 3 is a number of atomic number and 7 is the mass number. So the mass of the nucleus of the lithium will be 7 times mass of proton, right? Almost, because proton and neutron have the same mass. So roughly it will have the mass of 7. So nucleus का mass कितना है? 7 times mass of proton. And in normal lithium, who is revolving? Electron is revolving, right? So how will you write? You will write 7 times mass of proton into mass of electron divided by 7 times mass of proton plus mass of electron. Now you already know that mass of proton is much greater than mass of electron. Now just imagine 7 times mass of proton will be so much greater than mass of electron. So you can just say it is equals to 7 mp into me. You can neglect this thing and it will be simply 7 mp. So this and this will cancel. So your reduced mass will be equals to mass of electron itself. Okay. Now let's go to the muonic lithium. When you replace your electron with the muon, so now your nucleus is still same. Nucleus में तो वही रहे. कौन है? 7 times mass of proton. But now instead of electron, you have a muon. So now you have mass of muon divided by 7 times mass of proton plus mass of neon. Now 7 times mass of proton is much greater than mass of muon. So then again I can neglect this. I will get 7 times mass of proton. So I can cancel this again and again. So I will now the reduced mass I will get is 200 times mass of electron. Then you already know that energy is directly proportional to mass. So the new energy will be equals to 200 times old energy. So the new ionization energy will be 200 times the old ionization energy. Now you have to tell me that what is ionization energy?
Sir, is it the energy required to completely remove the electron from atom?
Yeah, energy required. Yeah, some
completely,
girl was
completely
okay.
remove the electron from atoms.
Okay. Is he correct?
But there are more than one electron in the atom, right, sir? So yeah, maybe it may not be correct.
Okay. So what does other says? So what is ionization energy? So first of all, if we are applying this model, then it is so sure that we are applying on lithium 2 positive. Okay, so don't worry about that. Okay. So yes, you are right. Two more people were answering the question, and Smile also answered correctly that it is basically energy required to remove the electron.
Sir, can you please again tell what about the other electrons?
We are taking lithium to both. Don't worry.
So only one electron.
One electron. Even if you are not taking, then ionization energy is basically defined as energy required to make an ion. Energy required to make an ion, or you can say energy required to remove valence electron. Whatever is your valence electron, whatever is energy required to remove that, that is your ionization energy. Okay, so can anyone tell me that what is an ionization energy for hydrogen atom?
13.6.
13.6.
Minus or positive?
Minus.
Sir,
Sure.
positive.
Oh,
Positive.
we have to give energy, sir. We have to give.
We have to give, so it will be
Yes, sir.
positive. You are sitting at minus 13.6, right? So in hydrogen atom, in the ground state, you are sitting at minus 13.6, and you want to come out. और अगर आप बाहर आ गए तो आपकी एनर्जी कितनी हो जाएगी? 0. So how much energy you have to give? Basically आपके ऊपर लोन है minus 13.6 का, and you want to come to the 0. So how much money I need to give you? Plus 13.6. Okay. Now you tell me that what will be the ionization energy for lithium? What will be the ionization energy for normal lithium?
Is it 9 times this value, sir?
Is he correct? 9 times of this? What do you say?
Z square.
Yes, sir.
3
Like,
times.
3 times or 9 times?
9 times.
Because the formula we studied is minus 13.6 into n square, sorry, z square by n square. So now let's assume that we are in the ground state.
N is
So
in
n
second, right? No, sir. Sorry, sir. No.
So
Yes.
n is 1. So for lithium, z is 3. So now your energy will be 9 times 13.6.
Excuse me, sir. Like I think, sir, like in lithium, the outermost electron will be in n is equal to 2, right?
N equals to 2. Why?
Like lithium, like first 2 electrons are in ground state, but the
Sir,
other
okay,
electron.
okay, wait. If you have 3 electrons, then don't use Bohr's theory anyway.
Oh, okay, sir.
Right? It means if you are using for lithium, it means 2 electrons you have already removed. Then you come to the Bohr's point.
So we have to always assume.
Yeah.
Okay.
That is basic assumption which is unstated. Okay. So then it is 9 times of this. But if I replace electron with muon, then this energy becomes 200 times. So now your energy will be 200 times 9 into 13.6. Okay, that is the case. Fine. So now let's see this. So 200 times larger than the normal lithium. So that will be your option number C, correct. So clear everyone? Bound, I think.
Sir, can
Yeah,
you
please.
just give a short again explanation for this question?
Sure.
Like from start?
Very certainly. So I have a lithium atom first, normal lithium. In normal lithium, what happens that you have a nucleus. What is the mass of nucleus? 7 times m of proton, because the atomic number of lithium is 7. Okay, good. And now you have an electron revolving around. In a normal lithium, you have just electron revolving. So let's find the reduced mass. Reduced mass is mass of nucleus into mass of electron divided by mass of nucleus plus mass of electron. Mass of lithium is 7 times mass of proton, which is nucleus mass. Now electron घूम रहा है, तो electron का mass me divided by 7 times m of p plus m of e. Now this thing is much smaller than this, so I can ignore this. So if I ignore this thing up, if I ignore this, what I will left with is 7 mp. So now then I can cancel 7 mp and mp. So I am left with this, that my reduced mass is mass of electron itself. That's it. So normal lithium के case में मेरा reduced mass is simply mass of electron. Now I have a muonic lithium. In muonic lithium what happens is मैंने electron की जगह यहाँ पर muon रखा हुआ है. And it is given to me that mass of muon is almost 200 times mass of electron. तो अब हम म्योनिक लिथियम का रिड्यूस मास निकालते हैं. सो अगेन मास ऑफ न्यूक्लियस कितना होगा? 7 टाइम्स मास ऑफ प्रोटॉन, क्योंकि न्यूक्लियस को तो मैंने टच नहीं किया. Instead of electron, now I have is muon. So mass of muon divided by 7 times mass of proton plus mass of neon. Again, ये चीज इससे बहुत बड़ी है, so I can just simply write 7 times mass of proton, and I also have 7 times mass of proton in the numerator, so this and this cancels. And mass of muon is basically 200 times mass of electron. तो अब मेरा reduced mass कितना आ गया? 200 times mass of electron. In the last question, in first question, I explained that energy is directly proportional to mass. तो अगर reduced mass 200 times increase हुआ है, तो energy भी मेरी 200 times increase हो जाएगी. Okay. So ionization energy पूछी है. Ionization energy is basically energy required to remove the electron. ठीक है. In lithium, what happens is that अगर lithium का electron जो है n ground state में है, n equals to 1 में, तो उसकी एनर्जी कितनी होगी? -13.6 इंटू जेड स्क्वायर, और लिथियम का जेड होता है 9. सो दिस इज माय आयोनाइजेशन एनर्जी फॉर नॉर्मल लिथियम. लेकिन अगर नॉर्मल लिथियम की जगह म्योनिक लिथियम लगा दूंगा तो मेरी एनर्जी 200 टाइम्स बढ़ जाएगी. सो दैट इज व्हाट इज गिवन हियर, दैट आयोनाइजेशन एनर्जी विल बी 200 टाइम्स लार्जर देन द नॉर्मल लिथियम.
सर
क्लियर एवरीवन?
ये एनर्जी निकालने की जरूरत भी नहीं थी वैसे ना, जो 9 into
नहीं,
13.
दैट आई वाज जस्ट एक्सप्लेनिंग. या दिस नो देयर इज नो नीड टू डू दिस. नो, that I was just explaining ki this is a, yeah, here we are this, initially I wrote only this much solution because that's enough. Okay. Now come to
Sir?
this year's question.
Sir?
Yeah, please. Yeah.
In ionization energy, the required the electron to remove valence shell. What is the difference between ionization energy and work function?
What is the difference between ionization energy and work function? So understand like this. In work function, what is happening? You are removing the valence electrons from the metals. Okay. Electrons are almost free. Ionization energy can be defined for any material. For every atom, we have some ionization energy. Work function is basically defined for metals. That okay, if you have metal, your electron is almost free. What amount of energy I should give so that your electron comes out of the metal? Basically, that is not a property of one atom. That is a property, average property of an entire material. Now try to imagine, एक metal के अंदर कितनी तरह के atoms होंगे? कोई ज्यादा अंदर होगा, कोई surface पे होगा. How can I define the same energy for everyone? कि ओके किसी में से भी इलेक्ट्रॉन निकालना है तो यही वर्क फंक्शन? नो, राइट. सो जब मैं वर्क फंक्शन की बात करता हूं, देन आई डिफाइंड इट फॉर एन एवरेज फॉर अ मेटल, कंप्लीट मेटल. लेकिन जब मैं आयनाइजेशन की बात करता हूं, दैट इज अ प्रॉपर्टी ऑफ अ सिंगल एटम ऑफ एनी मटेरियल. लिथियम एटम का आयनाइजेशन पोटेंशियल ये होगा, राइट? व्हाट डू यू से? And ionization energy is defined for everything, every atom. Work function is basically for metals.
Okay, sir.
Now let's come to this year's problem. Last paper which happened in CSIR net December 2024. By the way, you know that it comes in part C, so it is basically 5 mark questions. All the questions we did was 5 mark. Okay. So now it is given to us that ionization potential. Okay, again ionization potential is talking about of hydrogen atom is 13.6. Okay, we just studied that. Yes, this is true.
Sir, what is
yeah,
ionization potential and ionization energy? Is there any difference?
Obviously energy is equals to QV, right? So you can convert one to other, right? Just divide by E and you will get.
We studied ionization energy before, so I asked.
Yeah, so we can convert energy and potential, right? Energy is simply equals to QV, right? So divide by charge, you will get potential.
Okay, sir. Thank you.
If you look at the units, they have basically given you energy itself. Okay, so we can use one word or other for same. So ionization potential for hydrogen atom is 13.6 electron volt. Lambda h is the wavelength of, okay, lambda h and lambda d denotes the longest wavelength in Balmer spectrum of hydrogen and deuterium respectively. Ignoring the fine and hyperfine structures, ignore everything. What is the percentage difference between lambda h minus lambda t divided by lambda h into 100? So the first thing that we need to understand is that what is deuterium? Anyone?
2 protons. I mean 1 proton, 1 neutron.
What is deuterium, everyone? Anyone?
Sir, like basically hydrogen atom with extra neutron.
H21, like mass.
Right. So in hydrogen atom nucleus, you have one proton. That's it. And there is an electron revolving. But in deuterium, in the nucleus, you have one proton and also one neutron. And then there is an electron revolving. So mass of deuterium will be 2. Sorry, not 2. The mass of this will be 2 mp. But the mass of its nucleus will be just simply mp. Electron to dono mein same hai, so it will be me and this will be me. That's it. Okay. So now lambda h and lambda d denotes the longest wavelengths in the Balmer spectrum. तो Balmer spectrum study कर रहे हैं दोनों का. In one case we are studying the Balmer spectrum of hydrogen. In another case we are discussing the Balmer spectrum of deuterium. And Balmer spectrum mein we are looking at the longest wavelength. So first of all, let's write our spectral series formula. 1 by lambda equals to r, 1 by n final square, 1 minus 1 initial. So what is the n final for Balmer?
2.
Finally, we have to come to 2. Tabhi Balmer hoga. For longest wavelength, what should be the value of Ni?
3.
3. 3 or infinity?
3, sir.
3. Longest wavelength means lowest energy. So this is your n equals to 2. Now you tell me for which case energy will be highest.
Here
3 से
infinity.
2 आना, 3 से 2 आना और infinity से 2 आना.
Infinity, sir. Highest energy.
So infinity से 2 आने में energy जो है वो highest होगी. तो इसका मतलब wavelength minimum होगी. लेकिन 3 से 2 आने में energy minimum होगी और wavelength highest होगी. That is why for longest wavelength you have to come from 3 to 2. Why 3 to 2? क्योंकि 2 पे तो आना ही पड़ेगा क्योंकि you have Balmer series. And for longest wavelength you have to come from 3 to 2. Because उस case में energy will be minimum. If energy is minimum, then wavelength is highest. Okay, fine, clear. So 1 by lambda is equals to, yeah, please. Yeah. Any question?
Said got it.
Okay, great. So 1 by lambda equals to Rydberg constant, 1 by r, so 1 by 4 minus 1 by 9. So basically you get 5r by 36. Right, 5r by 36. So this is your 1 by lambda. Okay, good, very good. So we are done with here. Now you already know that I told you in the first question itself that 1 by lambda depends directly on the mass. So again, the thing is same. We have to use the reduced mass concept क्योंकि atom के अंदर changes हो गए ना. Atoms has been changed. So atom के अंदर changes हो गए. Z तो is same for both, right? Hydrogen and deuterium का Z same होता है. What do you say? Because number of protons in both of them is same. Mass number is changing, so Z is same for both. Only thing that is changing is basically आपका basically atom change हो गया. So again reduced mass concept. So हाइड्रोजन के लिए reduced mass कैसे निकालेंगे? न्यूक्लियस क्या है उसके अंदर? मास ऑफ प्रोटॉन इनटू मास ऑफ न्यूक्लियर इलेक्ट्रॉन डिवाइडेड बाय मास ऑफ प्रोटॉन प्लस मास ऑफ इलेक्ट्रॉन. Mass of proton I already told you what is that? 1837 times mass of electron. Right? And then 1837 plus 1 will be 1838 times mass of electron. If you solve this, you simply get 1837 by 1838 times mass of electron. But in deuterium, in the nucleus, you have 2 times mass of proton and then electron is revolving. Why 2 times? Because एक proton है और एक neutron है, दोनों का mass almost same होता है. Both of them have the similar mass. So it will be 2 times mass of proton into mass of electron divided by 2 times mass of proton plus mass of electron. 2 times mass of proton will be 3674 times mass of electron और उसमें मैं 1 add कर दूं तो it will be 3675 times mass of electron. So I got the reduced mass in case of hydrogen. I got the reduced mass in case of deuterium. All I have to find basically is this thing. How can I find this thing? In a minimum simplest way. So I have to find lambda h minus lambda d divided by lambda h. So the easiest way to do this question is divide this lambda h with both sides. So you will get 1 minus lambda d by lambda h. And then you have to multiply by this 100. So what I can do is I can find this ratio, lambda d by lambda h. So if I try to find this ratio lambda d by lambda h, I already told you that 1 by lambda is directly proportional to mass. It means lambda is inversely proportional to mass, right? So lambda d by lambda h is inversely proportional to mass, so it will be nu h by nu d. What is mu h? This is your mu h, so 1837 by 1838. What is mu d? This is your mu d, so 3674 into 3675. If you use the calculator, which is allowed in the exam, you will get 0.99973. And now I will put in this formula. You can clearly see in this formula. So one is as such, lambda d by lambda h I found as 0.99973. If I subtract both of them, I get 0.00027 and then I multiply by 100. This I can write as 0.003 into 100, which will be basically 0.03%. So 0.03% is your option number C. Yeah. So what about this question? Clear or not? Any doubt? What do you say? So who says that CSIR net does not repeat the question? I first showed you the questions which were asked in the previous year net. And then I showed you the question which was asked this year in 5 marks. So what don't you think that it was a very, very similar question?
यहाँ पे रिड्यूस्ड मास का कंसेप्ट क्यों लगा रहे हैं? मतलब इस क्वेश्चन को पढ़ के हम कैसे एनालाइज करेंगे कि यहाँ पे रिड्यूस्ड मास का कंसेप्ट लग रहा है?
What else is there? Tell me. Atom में changes हुए. First thing I told, whenever atom में changes होंगे तो reduced mass आएगा.
सर बट यहाँ पे तो ऐसा गिवन नहीं है कि एटम में लाइक हाइड्रोजन एंड ड्यूटेरियम एटम्स, 2 एटम्स दिए हैं अलग अलग.
हाँ, तो लिथियम और म्योनिक लिथियम भी तो 2 अलग अलग एटम थे. क्या Z चेंज हुआ कि हाइड्रोजन में Z1 था और तो Z सेम रहा, राइट? तो विद इन द सेम Z समथिंग एल्स इज चेंजिंग, राइट? अगर Z चेंज कर रहे थे तो आई अंडरस्टैंड. हाँ, अगर हम लेते हाइड्रोजन एंड लिथियम, फिर हम रिड्यूस मास नहीं लगाते, देन इट इज, यू आर राइट, -13.6 Z स्क्वायर, इसमें Z1 डाल दो, इसमें Z3 डाल दो, बट Z तो सेम रखा. तो फिर बदलाव किसकी वजह से आ रहा है? Z की वजह से तो नहीं आ रहा. फिर चेंजेस किसकी वजह से आ रहे हैं? रिड्यूस मास की वजह से. नाउ टेल, या व्हाट डू यू से? दैट इज व्हाई यू विल गेट एन आइडिया कि रिड्यूस मास लगाना है.
सो फर्स्ट हमें ये नोटिस करना होगा कि जेड में कोई चेंज नहीं है, तो वहां पे अगर रिड्यूस मास का कंसेप्ट लग रहा होगा तब वो उससे सॉल्व
लग जाएगा, तब तो रिड्यूस मास ही लगेगा, देन रिड्यूस मास ही बचता है फिर. ओके, जेड चेंज करना आईआईटी जैम एग्जाम में होता है. ये जेड चेंज कर दिया, सिंपल, राइट? इन सीएसआर नेट यू कैन इमेजिन इटसेल्फ कि वो आपको रिड्यूस मास पे ही लेके जाएगा. आउट ऑफ 4 क्वेश्चंस 3 क्वेश्चंस आर फ्रॉम द रिड्यूस मास. So that is why if you have done the PYQ, आपको एक आइडिया रहता है कि okay, this will be the possibility.
Yes sir.
Okay. Yeah, any doubt now? So this is the done with the CSIR net questions. Now I'm going to next exam. So any question till here? Now let's do the bacha questions, which is IIT JAM questions. Now you will have 1 minute solutions. So consider the Bohr model of hydrogen atom. So even they shared the model, they gave the name of the model. The speed of the electron in the second orbit is, what is the formula? 2.18 into 10 to the power 6 Z by N, direct formula. For hydrogen atom, Z is 1. For second orbit, N is 2. Just put the values, you will get the answer. Done, finish, understood, samjha sab? Clear? Any doubt? Direct use of the formula, nothing else. So now you will see that okay, question level is decreased because it's a IIT JAM exam. You have to just directly apply the formula. If you forgot the formula I gave you, then you are losing marks for yourself. Okay, so please remember all the formulas I am giving. Okay. In the hydrogen atom spectra, the ratio of longest wavelength in Lyman series to the Balmer series is, okay, so longest wavelength. First, you have to tell me the longest wavelength in Lyman series, and then you have to tell me the longest wavelength in Balmer series. So for Lyman series, 1 by lambda will be equals to R into 1 by n final square minus n initial square.
Yeah.
So tell me that what will be n final for Lyman? N final for Lyman?
1.
1. And what will be n initial for longest wavelength?
2.
2.
2.
So 1 by lambda will be simply R equals to 1 by 4 minus 1. Sorry, 1 minus 1 by 4. So that will be 3R by 4. So lambda will be 4 by 3R. Okay, 4 by 3R. Similarly for Balmer, n final will be 2, n initial will be 3. So then 1 by 4 minus 1 by I, which will be 5R by 36. So for lambda for Balmer will be 36 by 5R. Now you just simply have to do the ratio. So if you do the ratio, you will get 4 by 3R into 36 by 5R, which will be 5 by 27, which will be equals to 0.185. Clear, everyone? Understood? So if someone has done the question of CSIR net, then same question repeated in JAM. In the net, we saw that how to find the longest wavelength, and in JAM also they are asking the same question. Clear, everyone? Clear? Done. Next question. Now let's come to the gate question. What do you think? Isn't it exactly the same question or not?
Yes, sir.
First line. What is the meaning of first line? Longest wavelength itself, right?
The next upper level.
Yeah, longest wavelength, right? Longest wavelength. Because series limit is infinity to, let's say for Balmer, infinity to 2. First line will be 3 to 2. So 3 to 2 will be longest wavelength. Right. So in this also they are asking you basically the same question. So in the last question, what is the answer we got? 5 by 27. So in this question also the answer will be 5 by 27. So the question is only the wording of the question is changed. In the last question they said find the ratio of longest wavelength. In this question they said find the ratio of first line. So I told you the concept of first line in the last case. So if you are in a Lyman, then coming from 2 to 1 is the first line. And coming from infinity to 1 is the series limit. 2 to 1 will be the longest wavelength. Right. So either they can say longest wavelength ratio or they can say first line ratio. Both of the things are same. So the answer in this case also will be 5 by 27. What about this question?
Sir,
How many
sir,
of
can
you
you show the
now
answer
think?
of last question?
Yeah, 5 by 27. From here,
इससे
na,
पहले
I
का
got
सर तो सेम ही था.
we calculated. Yeah, so this na 5 by 27. That was a numerical integer. Okay, so here we had to put the value.
No, sir. Sir, I got the procedure, but finally it is 5 into 4 by 36 into 3, right?
This no, yeah, this, yeah.
Yes, sir. Yes, sir.
So this will be 9, right? So 9 into 3, 27, 5
Oh,
is
right,
the
right, right.
value.
Yes, sir. Yes, sir.
Okay, so 5 by 27. Okay. Okay, then how many of you can tell me the concept which will be used here? How many of you reach to the conclusion? What concept should I use?
That first line.
Reduced mass.
Reduced mass, right? Again, use a reduced mass. And I already told you that Rydberg constant is directly proportional to the mass. So this will be your homework. Try this question out. Nothing new in this question. Okay. So try this question. So that is all the questions I wanted to discuss. Then now tomorrow I will discuss the doubts of the assignment I gave. So that's all for the lecture for today. And now I'm open for your doubts.